issue.
Forests are constantly exchanging two big greenhouse gases, water vapor and CO2. Water vapor we don't really worry about from a climate change point of view because it cycles so quickly between the atmosphere and the surface, but CO2 is a big one. When you're looking at a healthy, sustainable forest system, you want to be taking in more CO2, storing it either in its tissue or as material in the soil, then it's releasing back to the atmosphere. So you want them to be happy and productive enough that they're taking in more CO2 than they're releasing back to the atmosphere. So as a tree grows, it grows leaves, and in the senescent season, most of them drop some of those leaves. Even conifers will shed needles, and as it does, it starts to break down and forms organic soils. So there's your carbon in the soils. Forests store less than a wetland would, because wetlands are usually covered pretty extensively by different types of mosses, and the mosses can grow several meters thick, and they tend to decompose a lot slower. So the bigger they get, the more water they need. So there's a link there we want to keep in mind to water cycling. We have to pay attention to how permafrost is melting, how that's affecting water and energy movement through the landscape, and how that feeds back to the atmosphere and the climate. How long that ice sticks around really determines how much water the plants at the surface can use. So there's going to be a pretty strong linkage, we think, with productivity. And whenever you impact the productivity of a natural system, you're affecting how much CO2 it can pull and keep out of the atmosphere. And a lot of debate and research now is what is that transition zone, which is really from the boreal forest into the subarctic. A third of the world's carbon is stored in that zone. So as we start to change productivity, especially start to thaw some of that carbon, there could be really important feedbacks. That's carbon that's been accumulating for hundreds of years. But more importantly, probably in that region, is the carbon that's in the soil. That's where most of the carbon is stored. And a lot of that, especially as you go north, is protected because it's encased in that permafrost. So it can't decompose, it can't be released to the atmosphere. But when you start to thaw that and warm temperatures, microbes are all of a sudden going to wake up and you'll start to lose a lot of that carbon stored in the soils.
So what would you say some of the major challenges are facing a society with respect to water?
Right. Well, I'd say that we have significant challenges ahead of us with respect to water quantity and, of course, with respect to water quality. Groundwater is really, next to the ocean, the largest source of water. And, of course, we can't drink from the ocean without a lot of engineering and energy involved. So groundwater is really our largest reservoir of fresh water in the world, representing about 2% of all our water. By comparison, the lakes and rivers, from which we draw much of our drinking water, represents only 0.007% of all of our water. Of course, water is overall a renewable resource, but as we know, groundwater flows very slowly, is replenished very slowly, and in many parts of the world we're over pumping the groundwater, which is causing groundwater tables to drop dramatically. It's causing subsidence of the soil. In many parts of the world, we're polluting the groundwater by dumping industrial chemicals, by a lot of our fertilizers and nutrients that we're applying to the land, pesticides, pharmaceuticals.
We're seeing noticeable changes in whole ecosystems. Anywhere you see a change, the effects of that change are being propagated through the whole system. And I think that's one of the challenges the climate community faces now, is trying to better understand, these effects.